with him. In this particular case, we started without him, and later we joined forces. Now, we found that 2-AG, the endogenous compound produced by the brain, and let's not forget that those compounds produced in the brain mimic, to a large extent, what the THC does. Or let's go the other way around. THC mimics the action of the compounds found in the brain. Now, 2-AG, we found that it reduces the production of TNF. Well, we were happy to see that. I'm not going to the technical details. Somebody's interested, I'll be glad to expand later on. Then we saw that 2-AG reduces the production of reactive oxygen intermediates. Now, reactive oxygen intermediates are formed in the body in quite high amounts. We obviously need oxygen, but when we have reactive oxygen intermediates, compounds formed from the oxygen, and they are generally, not always, but causing all kinds of problems. We still need some of them at a certain amount, like many other things. There is a level that we need, and above that we have problems. Much below that we have problems. We have to be in an equilibrium. Anyway, when these reactive oxygen intermediates are formed in large amounts, we do have problems. And we see that the 2-AG, one of the endocannabinoids, reduces the formation of reactive oxygen intermediates. The blue line is what we see without the 2-AG. The black line is where we see 2-AG. Then we looked, is that something we see only in the test tube? The answer is no. We see it also in vivo, in animals. So if that is true, what about cannabidiol? Cannabidiol, does it also cause the same things? The answer is absolutely yes. Cannabidiol reduces the formation of TNF. This is the first part. It reduces the formation of nitric oxide, which is also involved, not going to details, also involved in inflammation. It's also involved into chemilucence, which is the method for looking at reactive oxygen intermediates. So that was in the test tube, and we looked in vivo whether the cannabidiol does that in the whole animal. Obviously, we cannot work with humans. That's not ethical. And we saw that this is indeed what happens. Now, just in one word, it seems that cannabidiol, like many other compounds in the body, and like the endogenous cannabinoids, acts better if some of the additional compounds that are not active join forces. We call this the entourage effect. Entourage, the French entourage. And we saw that there is an entourage effect. So chances are that in the body we have an entourage effect of 2-AG acting together with other compounds which are basically inactive. So chances are that the same thing is happening with cannabis, where we may have an entourage effect, although it has not been definitely proven. There may be an entourage effect, namely there is an active compound, but other compounds which are basically inactive enhance its activity, and I wish there were more work on it. So the next thing was, okay, if we know that cannabidiol is active in vitro, is active in the test tube in doing all these anti-inflammatory things, is it active in the case of a real disease? And we looked at the inflammation of the synovium. Well, that's the part that is usually attacked in arthritis. And these are, of course, the knees and the elbows and the synovial membrane, which is the lining of the sacs that enclose the cavities of the movable joints. They are the first to be attacked, and we know that people that have arthritis suffer mostly in the elbows, in the knees, and so on. And we could show, together with Feldman, that if you take cells from animals that have arthritis, there is a model for arthritis, and we take cells, synovial cells, from animals that do not have arthritis, there is a difference in the production of TNF. Those cells that come from synovial, from knees and elbows, from synovial animals that have arthritis, they produce more TNF. There is more inflammation, of course. But if we have given those animals that have arthritis, we have given them cannabidiol, and then take the cells from their synovium, they produce less TNF. So obviously, those cells have been affected already in the animal. So we went on from there. Feldman has two types of animals in which, he has one type of animal which he can produce two types of inflammation, of arthritis. One is the regular type of arthritis, which is also seen in humans. It goes up and down. There's a week of an attack, arthritic attack, and then it goes up and down, up and down, up and down. And there is also another type which we can produce in animal, which goes up all the time. So we looked at these animals, and we saw that cannabidiol definitely blocks the inflammation. There is a clinical score. Again, I wouldn't go into details how this clinical score is being evaluated. There is a clinical score, and we can give the animals intraperitoneally, IP, and we see that at 5 milligrams per kilogram, the clinical score is very significantly lower than in those animals that didn't get CBD or got just the placebo. Then, surprisingly, we looked also at higher levels, and we saw that the cannabidiol acts at a certain level. If we give less than that, there is no action. If we give much more than that, we get less action. This is quite typical of all cannabinoids, both the endogenous and the real ones. And here is the chronic one. It goes up and down, up and down. But if you look at the end, after 40 days, and arthritis is a chronic disease, of course, we see that there is a very, very strong, very major difference between the controls and the animals that have got CBD. Now, this is an IP. Normally, patients will not get injections every day for their arthritis, so we tried it orally, and it worked orally in the same way. These are oral. I wouldn't go because of time. Now, we had, just switching gears a little bit, many years ago we had produced a metabolite of THC, which is an acid, and it has been found that this acid is anti-inflammatory. Many of these acids are anti-inflammatory, but unfortunately, this compound, this compound on the bottom, showed some central CNS effects, and we didn't want that. So we decided to make a compound which probably will be more active, but maybe won't have CNS effects. Unfortunately, it did. Wouldn't go to all the slides. It's the compound, the acid at the top. It also has, although it has been promoted as a compound which is a potent anti-inflammatory, which it is, a potent anti-inflammatory, it does show in our hands at least quite a strong CNS effects, and therefore we decided to make a compound out of cannabidiol, which originally doesn't have any CNS effect to speak of, so that we can use that compound. And indeed, and this is a very complicated synthesis, but on the left-hand side you can see the acid which we formed. We call it HU320, and this acid has no CNS effect to speak about. Let's see, if you look at a catalepsy, if you put an animal on a ring and it will move all the time, a mouse, but if you give a compound which causes catalepsy, it will move much less. Well, THC will cause the animal to move much less. Cannabidiol will not. And so the compound we produced did not cause any of these effects. So we looked at the activity of this compound, a derivative of cannabidiol, and for the sake of, because there isn't enough time, I will just go through these extremely fast. It does everything that cannabidiol itself does, except that it is much more potent. It reduces the production of TNF, it reduces the production of oxygen intermediates, and its effect on inflammation. This is another story. We take the paw of an animal and inject it with an inflammatory agent, and there is a inflammation of a sort. If we